So we're going to do conjugates part 2. This is Jacobit's Learning. Thanks for watching. So when you see this here, this equation, and I'm going to go ahead and rate it, 2 radical 3 minus radical 5 times radical 10, or square root of 10, plus 4 to the square root of 6. So it's 2 to the square root of 3, 2 times square root of 3 minus square root of 5, and all of this is in one bracket. So you see how you have brackets? On the previous video, I said to you that you should try and make sure you let the brackets tell you what to do. So I'm going to go ahead and put this here, and I'm going to say brackets dictate. Okay, sometimes your parents say the same thing, dictatorship, okay? They dictate. You have to take care of these. And why is that? Because you have PEMDAS, okay? Please. Excuse my dear Aunt Sally. PEMDAS, brackets dictate. So you have your first, outer, inner. And so you have 2. This is written down here in purple and in this kind of lime green color. So you have 2 times square root of 2 times square root of 10. That's your first. Okay, now your outer is 2, because it's outer here, times the 4 to the square root of 6. So let's go on to the next slide. Now you have your inner, you have your negative 5. Don't forget this negative. So it's negative 5, negative 10, square root of 10. That's your inner. And then you have your last, square root of 5 plus 4 plus 6. Okay, so it's last term in each bracket. Now you've got all your terms here to multiply, and you have brackets. Remember, we had PEMDAS. Parentheses are first. Okay, terrible handwriting, but you get the concept, PEMDAS. Okay, and so here we are. Please excuse my dear Aunt Sally. So now we're going to go on to the next slide, and we're going to multiply this thing out. Okay, 2 times, this is small, but try to look at what's going on. The square root of 3 times square root of 10 comes to 2 times square root of 30. So that's one term. Just get the concept. And here's what's going on. This 2 gets left alone because it is not inside the bracket. It's by itself. So since it's outside bracket, or outside the square root symbol, it cannot be multiplied by anything else. Because remember, you're doing like terms. Okay? So very simply, that's what you're doing. And that's your first term. So we're going to go ahead and hold it over. Okay, so here it is held over, 2 times square root of 30. Okay, now you have this term, 2 times square root of 3 times 4 times square root of 6. You have, look here, 2 times 4 is 8, because you're doing terms that are alike. And then these terms. A lot of people are inclined to do 3 times 2 times 6. You can do that, but you have to put it here. And then you'd go ahead and you'd have 3 to the square root of 2. And that might work if you do that already, but I'm trying to keep this simple so we don't get confused on what happens. So this is the square root of 3 times square root of 6. Combine them together under one bracket. You have 3 times 6. And then you can do your least common multiples later. Okay, that's what that is, and it's under the square root bracket. Okay, so that's your next term. Okay, so now you add these terms together, and this is simply you're multiplying. There's nothing out here. Remember, this is the square root of negative 5, square root of 10. You have to keep the negative here, so it's a negative 50, square root of 50. Okay, so all your terms are over here lined up, right? 2 times square root of 30 plus 8 to the square root of 18 minus the square root of 50. Okay, now, what about your last term? There's nothing in front of this -5 except a 1. So even if you did -1 times 4, you would get -4. So if you have to think about this, I know in years of teaching, a lot of students forgot what this was, and I sometimes, that's why you always make sure you take care of this term here, and you always make sure you don't forget to carry your negative over. So I'm going to go ahead and highlight this term, carry it, it's negative. Okay, and so that's -4, guys, -4 to the 30. We brought it down over here, and I'm going to highlight it here. This is your last term, right in front of you. Okay, now, what are you going to do with all of this? What two terms do you see that are alike? You see 2 to the positive, I'm sorry, square root of 30 minus 4 to the -30. Okay, now look, positive 2, square root of 30, minus 4, square root of 30 gives you the -2 to square root of 30. Plus, you still have all of this to get together and add up. This square root is on its own, this is on its own, and this is on its own. So what are we supposed to do? You're supposed to now take what's under your square root and start branching it. Okay, like you did when you were in elementary school, you're going to do trees. And you're going to do branches, and you're going to see how far you can go down. Okay, you call these factor trees or factor roots. That's what these are. So 15 times 2 is 3 times 5 times 2. There is absolutely nothing in common here. None of these have a match, so you have to leave this where this is. Okay, this has something in common. The square root of 18 is 9 times 2. These two cross, and you're going to get the square root. Remember I said on the other slide you could go ahead and do that now if you wanted to, but here it is in front of you. Same thing here, but remember, this is going to be minus 5 square root of 2. Okay, so let's go on to the next slide. And here you have what's going on. Okay, since you had 3 to the square root, you had 24 to the square root of 2. Okay, and 24 to the square root of 2. Okay, and then you had this over here, the same, 5 to the square root of 2. Let's see if we can do something else. Okay, you had 8 to the square root of 2 times 3 times the square root of 2. That's 24 to the square root of 2. And then you had 25 times 2, but guess what? 2 is left alone, so you had 5 to the square root of 2. And we're going to take that on to the next page because, see, if you look at it, you have common terms. Okay, 5 to the square root of 2, 24 the square root of 2, but you have a negative sign here. Next slide will show you what you're supposed to do. That came from the other 8 from the other page. They got combined, and now you have 24. Now look, these two terms are under the radical, and they're a square root of 2, square root of 2, so you have a like term. So since you have a like term, can't you combine them? And then you'll get 19 to the square root of 2. Oops, I'm trying to make this a 5, and it's not. It's square root of 2. Okay, so let's go on to the next page. And you cannot reduce radicals any further, so this has to be your answer. Okay, this problem is a little bit easier. If you can grasp the concept on the first slide, you can certainly grasp this. Already you have 4 to the square root of 3 plus 7 to the square root of 3. The whole problem is all under one bracket. So guess what? Your 4 and your 7's become 11. This becomes 11 to the square root of 3. These are like terms. Can you get what's going to go on next? Go ahead and let's see if you can see what happens on the next slide, because step 1 is already here. Okay, so step 2 was that 11, because these were combined, the square root of 3, and then this is this 2 minus square root of 3 over here. The minus sign is here on the lower number. This was a positive 11 because both of these terms were positive. So now guess what happens? It becomes 9 to the square root of 3. Simple, simple. Try to go through these and get the concept. Okay, 3 to the square root of 7 minus 2 to the square root of 28. Can you already see something that's going on here before you solve that? If you do your factor trees and you start thinking of this, that you have a 7 here and you have a 4 here? Because if you can think about that, and this and that and other, and think about what's going on, you'll get faster at these. And then when you see them on the SAT or on the ACT, they'll be easier for you to do. Okay, so this was done again, 7 times 4, you had, and then the factor tree came out, it was 2. So already you're going to have 2 times 2 to the square root of 7. So now you have something in common because you have 3 to the square root of 7 over here. But guys, make sure when you go and do this, you're going to make this 4 to the square root of 7, and this is a negative sign in front of it. Please don't forget those signs, because without the signs, the whole problem becomes wrong. So now you had 2 to the same 2. This is what we were telling you to do. This was just done on the same slide. This is just a recap of that. And now you have 3 to the square root of 7. This is from the original problem. Nothing changed. Minus 4 to the square root of 7. So what's going on, guys? Equals negative 1 square root of 7. It's ugly. It looks like I'm trying to. Let's go here. Guess what? Let's go to the next slide. Negative 1 square root of 7, or just plain negative 7, because this 1 here is already implied. Any number is already implied. Okay? And this is your answer, either one. Negative 1 to the square root of 7 or negative 7. Okay. 2 to the square root of 50 minus 3 to the square root of 32. And already the factor trees were done for you. If you want to go down, this is a 5 and a 5. This is going to come out. This could be ugly if you're not thinking about what's going on. So let's go on ahead and look at the next slide. It is ugly. Look at all this stuff. You had a 2 over here. These 5s canceled out, and this is this 5. This 2 is this 2. What's 2 times 5, guys? 10. What's going on with this? This is under the radical. So it's 10 to the square root of 2. You have a new number. Minus 3, 2. What came out and what came under here? You had 2 times 2 times 2. You had one radical left, and you had 2 2's. So you had 2, 1, 2, this 2, and that's times 4. But you had a 2 left over, square root of 2, and you'll see this a lot cleaner on the next slide. So on the next slide, you get 10 to the square root of 2 minus 12 to the square root of 2, and then when you subtract because of this negative sign, it's negative 2 to the square root of 2, and it comes out okay. Let's take a look at that. We're going to come on to the next slide. They're trying to confuse you here, guys, by putting this extra bracket. I want you to go ahead and take a look at what's going on there. And I want you to see if you can see the correlation. You're doing the FOIL method. And as you're doing the FOIL method, okay, here's what's happening to you. So take a look at that method. Okay? So you took a look at this and you had 6 times the square root of 3, and all I did was just go ahead and combine the square roots. First, then you had 6 times square root of 2. Why didn't I go 6 times 5 is 30? Because it's not a like term. Square root of 18 plus 5 to the square root of 12. Can we do any further? I think so. You can do factor trees. Let's go on to the next slide. 9 times 2 is 18. What else? 6 times 3 is 18. You could do 6 times 3 as a factor tree, but look what would happen. You'd still get like this 3 and this 2, and these 2 3s would still cancel out. So this is done for you. This gets to be a mess. These 3s are going to be pulled out. You're still going to have this under the square root bracket. And same thing, 3 and 4, your 5, you got a set of 2's coming over here from this factor tree. And so once the 2 2's cancel out, they come over here. Square root of 4 is 2. You guys know that. Anyway, but if you do it as a factor tree and do this, you can simply see how you're crossing things out and how they come over and cancel each other out. Okay, and that's what they're doing, they're canceling. So you have 5 times 2 with the square root of 3. So when you go on to the next slide, you put all that together, you have 3 to the square root of 2 plus 10 to the square root of 3. Don't let this confuse you, because people are inclined to go 13 times the square root of 6, and you don't want to do that. You'll confuse yourself. You just want to leave like terms, like terms. This is the correct answer. It's Jacobit's Learning. Thank you so much for watching. We hope this helps you. If you have any questions, look us up and go on our website. Go on this and see if you can find out what like terms are. Thank you. Have a good afternoon.